Hi, everybody. This is Mr. Russell. This is my dog, Bagel, or Mr. Bagel. Just wanted to introduce you all to him. So he'll be right down here, um, the class during this class. Guys, I'm going to keep this one really, really short. The one on energy that I recorded yesterday was 30 minutes, or a little more than 30 minutes. That will not be the norm. This one will be pretty short. So today's activity, we're going to get a little bit more into nuclear power. What I'm going to show you guys how to do here on this video is just to calculate half-life. And a method for doing it, I did show you in class, but you do get questions on the AP, so I just wanted to make sure you all know how to do it. If you notice, I'm here in albert.io. This is the teacher view right here. We're only going to look at one question here, that's a half-life question. But before we do that, I just want to remind you guys that today your Flipgrid video is due, and also your response to another student's Flipgrid video. I hope you have time to do that before the due date, before the due time, which is all on your Flipgrid. I know you guys are way behind. Your albert.io assignment with the 50 questions on energy is due Friday. And guys, I know you are not going to be happy about this because you're really far behind in my class already. You're going to get another albert.io on nuclear power today that will only be 10 questions. But I'm a little disappointed you guys aren't making more progress. So hopefully you guys will start to pick up today. I don't think what I'm asking you to do is unreasonable. If I could see more progress that you guys are trying and not getting very far, then I would maybe understand an argument that I'm asking you to do too much. But since I'm seeing most of you have done nothing, I don't think that's a convincing argument. So let's get into this so the video doesn't end up being too long. So question reads, a scientist has a radioactive isotope that has a half-life of 50 years. Approximately what percent of the original sample will remain after 250 years? So one thing that's important to remember is what is a half-life. So radioactive compounds are not stable. They do decay over time into decomposition products. We don't need to worry about what those are for this class, but they decay at a rate that is predictable, and that is called half-life. So the definition of half-life is what it sounds like. That is the time it takes for a certain amount of radioactive compound for half of it to decay. That's what a half-life is. Okay? So actually, there's a good way to set this up in a little diagram, and I showed you guys how to do this in class, but I want you guys to do this on paper for the problems you get. So just basically set up a grid kind of like this. You can actually go forever because half-lives technically go forever. I'm going to put on the top what we're talking about. This is HL for half-life. How much? Well, I guess that should be, sorry guys. How much? This could be in percentage, it could be in grams, it could be whatever. And this is time. Okay. So for half-life, you're just going to count from 0. It's important to remember that you always start with 0 on these charts, not 1. So 0, 1, 2, 3, 4. I'm going to put one more at the bottom. Remember, you can keep going these forever, but we'll probably be able to stop at 5. Your time at half-life 0 is always 0. Okay, so let's go back to the question really quick to see what they're asking about. If the question is dealing with something in grams, how much is going to be in grams? If it's dealing with percent, it's going to be in percent. And we don't know what the half-life is. Well, it does tell us here. So all our answers are in percentages. So we're talking about how much. Approximately what percent of the original sample will remain after 250 years? So we're looking for that. What is the half-life? It tells us here it's 50 years. So it's important to remember that one half-life is 50 years, right? Not 0. So it's 50. Sorry, guys, I'm pushing a button on this thing. 50 years, okay? At 0 years, you will have 100% because nothing is dissolved. Or, sorry, dissolved is not the right word. Nothing is decayed. At one half-life, it's called a half-life, so what percent is half? 50%. And basically, every half-life you basically add 50 years. You add the amount of the half-life. So our half-life is 50 years, so we're adding 50 years. So here 50 plus 50 is 100. 50 plus 100 is 150. 150 plus 50 is 200. 200 plus 200 200 plus 50 is 250. So based on the question, that's what you want, 250. That is 5 half-lives, but that's not what the question's asking you. It's asking you how much is left. So now we just have to do some simple math. Remember, this is how much you have left after the half-life, so it's just going to be half of every time. So half of 50 is 25%. Half of 25 is 12.5%. Half of 12.5% is 6.25%. And then half of 6.25 is 3. Let me put this 125%. So that's going to be your answer right there, 3.125. Sorry, it's kind of like squished down on the bottom there, but that's it. So let's go back to the question. And we have answers 3, 6, 8, and 9. Of course, the question says approximately, so it doesn't have to be an exact number. So I'm going to click it. I get to do something on my teacher version that you guys don't of Albert.io, and then I get to look at the answers right away. And we can see if that's right, and it tells me it's correct. Here's my explanation. And we can see that's something you don't get to see. Is that 69% of students who try to answer this question get it right. The rest get it wrong. So I'm going to give you 10 questions based on half-life and other things with nuclear energy. So I'm not going to waste time in the video talking about the other things I wanted you guys to learn, which is how nuclear fission works and how a nuclear power plant works, because you'll notice in your Google form, you need to put your name, obviously. There are 3 videos. I kept these videos very, very short for you guys because I know you have a lot to do. All of these videos are under 4 minutes that explain how nuclear fusion works and how, not nuclear fusion, but nuclear fission works within a nuclear reactor. The first one is from the HBO miniseries I told you about, so you get to see a little piece of that. Answer the questions, make sure you follow the instructions. Part B is something important about on the AP. You will get some Albert.io questions, and they do pop up on the AP about nuclear disasters. There are 3 you need to know about. They are really important. 3 Mile Island. Make sure you answer all 3, A, B, and C of them. Answer here. Chernobyl, which again, that's what that miniseries is about. Here, answer all 3 of these prompts. You're going to answer the same prompts for all 3. And the last one is Fukushima. There are 2 videos on this one. But again, they're both very short, and put your answer here. So this should take you maybe an hour, no more than 2 hours. So if it takes more than 2 hours, definitely let me know. It shouldn't take you more than 2 hours, though. But let me know how long it takes you, please, just so I can get a sense of how much time you're spending on this. And guys, please finish your other work. If you have problems recording your videos for the Flipgrid assignment, please tell me. So far, nobody has told me they have a problem, so my assumption is that you're just not doing it. I'm not going to change the due date unless I hear from you guys that there are problems and that they're credible. Otherwise, I think you guys all should get to work. There's a lot for you guys to do. I know many of you are doing work for other classes too, but I think what I've asked you to do is pretty reasonable. So anyways, I'll give you more work tomorrow, so it's more reason not to get behind. And I'll see you in the morning with more work. So get going.